we have more circle formulas, 4 formulas that we will use, and we will actually go through the proofs for 2 of those. Our first formula is when we have lines crossing inside the circle, but today we want to know about the measures of the angles and the arcs, the degree things. Day before yesterday, we had ones that crossed inside the circle, and we had a formula for the lengths of the segments that you would see. When you have this, your formula is the angle equals the arc plus the arc divided by 2. Do not memorize these as x equals a plus b over 2, because sometimes in the problems, x will be here, sometimes it will be out here, it can be in all sorts of places. Memorize it as the angle is the arc plus the arc divided by 2. If the lines cross outside the circle, we have a similar formula, except this time the angle is one arc minus the other arc over 2. It is always the farther arc minus the closer arc in order to be the bigger arc minus the smaller arc to get a positive number. Just for emphasis, I have written out what I just said, that here the angle is 1/2 of the big arc minus the small arc. And I've also typed out what I was saying, that the unknown could be x or a or b. So on the book problems, 2 of these will be numbers that they either give you or you can figure out, but the missing one could be anywhere. Do not just automatically say the missing one equals the 2 you know divided by 2, either adding or subtracting them, because it makes a difference whether the unknown is out here where x is or it's in here in the numerator, and we'll see that in an example in a few minutes. Our third formula is if they cross outside, what's the relationship between the lengths of these segments? Now, day before yesterday, we had the formula if they crossed inside, and we had one piece times the other piece equals along the other chord. This time, it will be the outside part times the whole thing. It is not a times b. It's a times a plus b. Outside part times the whole thing equals the other outside part times the other whole thing. And we'll prove this one in a few minutes. The final formula for today is going to be a special case of Formula 65. It is going to be where instead of both of these being secant lines, one of them is a tangent line. In that case, we still will have outside A times the whole thing, A plus B, will still be equal to the outside times the whole thing. The outside is C, but C is also the whole thing, so that one becomes A times A plus B equals C squared. But you don't have to worry about memorizing that completely separately if you learn these as the outside times the whole thing equals the outside times the whole thing, and if outside and whole thing are the same, you just get something squared. Okay, moving to the proof of the first one, we want to prove that the angle is arc plus arc divided by 2. So we have a circle and we have 2 lines crossing inside the circle somewhere. We've picked one of the angles, it's labeled angle 1. That's the same as its vertical angle over here. And so then the arcs that would be intercepted by these vertical angles will be AD and BC. And we want to be able to come out with it's add the arcs and divide by 2. So do you agree that that's equivalent to what we had on our formula page? Anytime you're doing a proof, it is okay to add a line in there if it's going between 2 fixed points somewhere in the thing that you're trying to prove. So I have D and B, those are clearly 2 points, and I am going to add a line that goes from D to B. So now I have a triangle in there, and that triangle is going to help me with the proof in a moment. The other thing that it is okay to do is to label some angles if that would make it easier to write out the proof. So I'm going to label this one as angle 2, this one is angle 3, and this one in here is angle 4. That way I can just say angle 4 instead of writing out angle BPD and trying to keep all of those letters straight when I name things with 3 different letters. Just make the proof a little bit shorter. Since I have a triangle in there, can anybody tell me, or can everybody, I hope, tell me something about the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4? Everyone? It's 180, and what's our reason? Triangle sum. In addition, I sure hope everybody can tell me something about the measure of angle 1 plus the measure of angle 4. What does that equal? 180, and what's that reason? Okay, they form a straight angle when you put them together. So now I have 2 things that are each equal to 180. So is it true that those things have to be equal to each other? So we're going to write that down. That means the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 4, and that will be our transitive property. Is there anything that's the same on both sides? Is it okay if I subtract the measure of angle 4 from both sides of an equation? So if we do that, we now have the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1, and that's just because we subtracted the measure of angle 4 from both sides. So I'm trying to prove something about the measure of angle 1, right? And I have something in my proof now about the measure of angle 1. I want it to be arc plus arc over 2, but what I have is angle 2 and angle 3. With the place that I drew that extra line, what kind of angle is angle 2 in this circle? What are we going to have there? Johnny. It's going to be an inscribed angle. So the measure of angle 2 is going to be half of this arc that it intercepts, right? So measure of angle 2 is half of the measure of, what was the name of that arc? BC, because it is an inscribed angle. And isn't angle 3 also an inscribed angle? So measure of angle 3 will be half of the measure of the arc it intercepts, and it intercepts arc AD. So, okay, if I substitute, I've got measure of angle 2 plus measure of angle 3, so I'm going to put these halves of arc measures in there, and I have the measure of arc BC over 2 when I substitute for the measure of angle 2, and I have the measure of arc AD over 2 when I substitute for the measure of angle 3, and that's the measure of angle 1. So if I put measure of angle 1 on the left, everything else on the right, so that'll be my symmetric property. If I get my common denominator, and if I use the commutative property so that I can write AD before BC, I think I will have this. So if I use symmetric, commutative, and common denominator, I have measure of angle 1 equals the measure of arc AD plus the measure of arc BC all over 2, and that is what we wanted to prove. So does anybody have a question on that? Be sure you keep track of your notes so that if you have this on a homework problem or you have this on a notebook quiz of are you taking good notes in class, you can get this correct. Any questions about it? Okay, are we ready to move on to the other proof? Okay, for the other proof, we want lines that cross outside, and we want to be able to prove outside times the whole thing, PU times PT equals the other outside PS times the other whole thing PR. For this one, I am going to recopy the picture twice because I want to add some lines that'll give me some triangles in there, and I'm going to get cross-eyed if I try to keep track of it all in one picture, so I'm going to draw them separately. So here are my redrawn pictures. Do you agree they're the same picture, just I've added one line on the left and a different line on the right? I'm trying to prove segment times segment equals segment times segment. And I've had that sometimes in some problems if I've been able to get a proportion where I've had side over side equals side over side. And I believe we have three kinds of places where we've seen proportions. We've had proportional line segments with parallel lines. We've had proportional line segments when we've bisected an angle and a triangle. And haven't we also had proportional line segments when we've had similar triangles that corresponding sides are proportionate? So with this one, I've drawn the triangles. Do you think I might be able to get that those triangles are similar? So that's where we're going with this proof. Question? Pause this 1 second. Okay, so we're going to try to prove that these triangles now are similar so that we can set up that ratio. So when I added those lines, I got triangles that I didn't have in the original picture. The other thing that I got was I got an inscribed angle in each one of those pictures. So over here, R is my inscribed angle. So I know that it is going to be half of the arc that it intercepts. So it is going to be half of the measure of arc SU because that's an inscribed angle. And my inscribed angle over here is going to be T, and it's going to be half of the arc that it intercepts, but it intercepts the very same arc. So since they are both half of arc SU, that means R and T have to be congruent. They have to have the same measure, and that's by the transitive property as well. So we'll mark that those angles, whoops, how did it do that? Haven't had it do that before. So we'll mark that those angles have to be congruent to each other. Okay, if I'm trying to prove similar triangles, the way that we do that is angle, 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 similarity. Do I have any other angles in there that I can get congruent? Triangle on the left, triangle on the right. Any other angles that are going to have to end up being congruent to each other? Maggie? P is going to have to be congruent to itself. And the reason for that, remember, these are both really just the same picture. They are both actually this angle P, so it's going to be reflexive property. So angle P is congruent to angle P reflexive property. Two sets of congruent angles. What else, Shane? I've got triangles with two sets of congruent angles, so what else do I know? Exactly, we know now that AA implies AAA, so these angles must also be congruent. So let me get that written down in here. A little more room there. So that's going to be I want to make sure I get these in a corresponding order. I can say that angle, what's that letter up there, RUP. So I did blue, green, red on the left. So I'm going to do blue, green, red on the right. And now I have all three sets of angles congruent. So I can say that the triangles themselves are not congruent, but similar. And again, writing the vertices in the corresponding order. So now we have those similar triangles. Now we'll be able to set up some ratios. We'll be able to set up ratios because corresponding sides of similar figures, in this case similar triangles, are proportional. Going back to what I'm trying to prove, I have 4 sides in this product. I've got 6 sides when I'm talking about similar triangles, so I want to try to figure out the right 6, or the right 4 to set up my proportion. One of the ones I need will be PU. So I'm going to come down here to my similarity statement. PU is only in that triangle on the left, and that is last middle. So I'll put last middle over last middle, so over PS. So I've got left triangle over right triangle with those corresponding sides. This one is also going to need to be left over right when I write that ratio, because that's how we write proportions with these. So now I'm going up, I have PU and I have PS. I need to find PT and PR, hopefully as corresponding sides. So coming back down here, I'm going to look for PT or PR, and I know I need the left triangle on top, so PR is in the left triangle. Last first over last first, and that was the other one that I needed. So I have my ratio set up. Last step, I'm going to take my cross product, and I'm going to carefully look at what I'm trying to prove so that I do the cross product in the right order. I need PU times PT first. So PU, PT is one cross product. And then I'm going to look back at what I'm proving. I want that to end up PSPR, which I do indeed get from the other cross product. And we've proven that one. So that was the hard part of today. Using the formulas, these are actually very short, easy problems. So any questions on the proof before we move into using the formulas? Yes? The cross product, PU times PT, because we had the proportions, and then PS times PR going the other direction. If you prefer, you could say you multiplied both sides by PT, PS, and canceled. That's an equivalent way of saying that. Maggie? They might, you never know. Or they might end up on a notebook check when I just say, go back to your notes from this day, this lesson. Whatever it takes to have us focused and paying attention so that we understand these. Question? All right, let's move on then to some of the problems. These go a lot faster. Here the lines cross inside. Will my formula have a plus or a minus? It will have a plus. And we start with angle equals. Which of these is the angle? So we have x equals 100 plus 60 over 2. So everyone, what does that mean x equals? See how easy these are. Okay, next one. Now they cross outside. Will the formula have a plus or a minus in it? It will have a minus. The formula starts angle equals. Which thing up here is my angle? Y is the angle. I'm going to subtract the arcs, and it's always going to be the bigger one minus the smaller one, the farther one minus the closer one, so that we get a positive. 170 minus 80 divided by 2. What's 170 minus 80? What's half of 90? So y is 45. As long as we set the formula up correctly, very easy problems. Okay, this one, a little bit of a twist. They cross outside. Angle, so will the formula be plus or minus? Minus. We need angle equals. What is the angle on this one? It is 35. This is one that I was talking about. You do not just put x equals. Angle equals. Then we can do 170 minus x divided by 2. Multiply both sides of the equation by 2. 70 is 170 minus x. So everyone, what is x? It is 100. It is not the same as x equals 170 minus 35 over 2. 135 divided by 2 is not going to give you 100. So you see how it makes a difference. Okay, different twists with this next one. So they cross outside. So plus or minus in my formula. Minus. So z equals 150 minus 100 over 2. What's wrong with that? It's not the correct arc. I need this arc. How can I get it? So circle sum, very good. So 360 minus the 250 that we already know. So 360 minus 250 is how much? 110. So z will be 150 minus 110 over 2, which gives us 20. So, are we good with the ones that are angles before we move over to the last couple of examples with segments? Okay, this time they cross outside, so it is going to be outside times the whole thing. So there's my top one. Equals outside times the whole thing. So there's the bottom one. Now, we have to be careful on this. Can you always divide by things that have variables in them? No. What do you have to watch out for? You might accidentally be dividing by what? What causes a problem when you divide? You might accidentally be dividing by 0. So we need to, if we want to divide by a plus 4, we have to make sure that it is not 0. Are you confident that a can't be negative 4? Why? Because it can't be a segment right here. So a can't be negative 4, so we're okay. So we could do that and just say a equals 4. If we can't do that, distribute, solve the quadratic. And you'll have some that go both ways as you do these kinds of problems. Question? You've got a puzzled look on your face. No, that's because I divided this and got 4. If it couldn't be negative 4, I would have had, or if I didn't know I could rule that out, I'd have to do a squared plus 4a, distributing here, equals 4a plus 16. And because of the way the 4 repeated, I'm going to have, I could subtract the 4a's and have a squared is 16. A is plus or minus 4, except it can't be negative 4, so a is 4. Sometimes we'll have to use that process because we won't have the nice symmetry with the 4's and the a's in both of them. We just start off on kind of easy ones. Last one, this time we have a tangent line. So for this one, we have outside times the whole thing, so b times b plus 12 equals. For the tangent line, 8 is outside, 8 is also the whole thing, so 8 squared. So we have the quadratic b squared plus 12b minus 64 equals 0. And since that starts with 1b squared, let's see if we can factor it. Can anybody come up with numbers that multiply to be negative 64 and add to be positive 12? You got them? So 16 and a minus 4. So that means b is negative 16, b is 4. Do they both work? What doesn't work? Negative 16, because this cannot be a negative length, so b equals 4. Now, if we had a problem where the segment was 2 minus b instead of b, would 4 have worked if that was a segment? Because then the segment would be negative. It's not whether the variable is positive or negative, it's whether the segment is positive or negative. So any remaining questions? We've covered a lot today.